Welcome back. An update on how the Is It Time for Tea machine progress, how we're getting on with it. There's the head still in position. Just as a recap, we've got this temporary base into which the mechanism fits that's going to work the head, the eyes, the mouth, the neck, and also rotating it. I'm using servo motors. There's the two here. I'll try and zoom in a bit. There's the two here to work the eyes and the head, the angle of the head, and a motor down here which turned out to be the best way of moving the mouth open and closed. One thing I have added to this, because if you have watched the last video you'll know that the clacking of the mouth as it opened and closed was getting a bit much. It was too noisy. So I hummed and hawed about it and then thought, well, ideally we need some sort of stop. So it's a bit difficult to see because I haven't painted any of this yet, but I came up with a little assembly here that's screwed onto these two verticals with two cams, and the cams are cut out of 10mm acrylic on the laser cutter, and I covered them in red felt. As you've heard before, I do like having little touches of red here and there because it makes it look really attractive. So one of the cams is very difficult to see. The cam down there adjusts how high this lever, this pulley, can be driven up by the motor, and this top cam, it's all gone a bit wobbly now, this top cam adjusts how far down the pulley can rest when the motor switches off. So in effect I'm hoping I can adjust it accurately enough so that the mouse doesn't clack every time it closes. It can stop just above that. So that's one step. And the second step is to have started working out how to rotate this whole assembly, because if you remember, this whole thing is going to rotate so that the face or the head can look around where it needs to. And I thought about having a motor actually fixed to this, but then I thought, well, hang on a minute, add a pulley to it because I want a hole down the centre to be available to let the cables disappear, because I've got all these wires coming from the motors. Using the second Lazy Susan I think it is, bearing at the bottom, there's the nice hole in the middle which is perfect to allow wires and things to work the motors. So I designed a laser cut another pulley. It's always a bit of a toss-up now because now I've got the 3D printer, the sky's the limit. Do I laser cut it? Do I 3D print it? This time I thought I'd just laser cut it because it is so quick, and that's one of the benefits of laser cutting. And I also decided to drive this with this lovely, if I can focus on it, this lovely spring drive. I've used this on the Epizooscope as well. Originally I got it for the, what was it, the revelator, the climatic revelator, because I realised that this can change direction and drive in, you know, any direction you want. But it turned out with the revelator that it was too springy, obviously because it's a spring. I didn't think that would have too much effect, but it really did jerk round as the chimes turned and as the little scene carousel turned. It jerked and it jumped and it was very unpredictable. So in the end, that's when I came up with the idea of using the ball chain. But for this job, because the servos, like I said in the part before, they work at full speed. They go from wherever they're at to the new position that you send them via the signal wire as quickly as possible, because that's what you need with radio control stuff, steering and things. I don't want this. It's quite a large thing, this central part, and having this directly tied into a servo motor is going to put a lot of stress and strain on all the bits and pieces. So, to cut a long story even longer, this is a pulley, here's this spring, it's going to roll round both sides like that, over a couple of little bearing pulleys like this, and I've used these before on the Barometric Prognosticator 3 and the Revelator because they're ideal. They've got bearings in the centre and they've got the V-shape, which is perfect for running chain or springs like this over. So I'm going to have two of them down here, changing the direction from horizontal, if you like, to vertical, and then have another pulley. Let's go out and back a bit, always the wrong way. Another servo up here connected to a pulley so I can, it's now slipping downwards of course. Another servo here with a pulley connected to the both ends of this this spring, so as this turns that will turn. Because servos can only turn, or these ones, through 180 degrees, I might make the pulley on this a little bit bigger so I can go a little bit further with the head, because as it's going to have to study two sets of gauges and dials, it might be quite useful for it to go a little bit further than 180. Anyway, that's something for the future. To cut an even longer story short, vaguely, because I now need to work out where to put this solenoid, where I'm going to fit it, I think it's time to actually think about and consider the enclosure for this whole thing. So far it's just been working in this mock-up so I can just get everything roughly sorted out, but I want to get that in the right place. I've also got the bottom of this hanging, you know, it doesn't reach down to the bottom of this frame, so it's all getting a little bit vague. I think I'd rather now consider the enclosure. So, enclosures. Well, the first one, the first steampunk machine I made, was an installation at a school, and that was huge. That was the height of a room, so 2.4 metres. So I used plywood reinforced with pine battens and stained it all nice dark oak colour and polished it to make it look like a sort of Gothic style, Victorian Gothic, which I love, with routed out mouldings and things around the stained glass window. That worked very well. Then the second one was the Barometric Prognosticator 2, I think. And that was, I made the frame for that, the enclosure, from MDF and covered it to get it looking like a proper wood with flexible veneer, self-adhesive veneer, which is fantastic. I used it on some speakers that I designed a few years back and was really impressed with how it can cover any sort of curve or surface, sticks down instantly as long as you rub it down properly, and then you can stain it and polish it and varnish it and anything else that you would with normal veneer. So I used that to get the curved top of the Barometric Prognosticator 2 where the clock is, and to cover the rest of it with the curves and everything, the radius. It was really nice and worked well. But then subsequently I've mounted them all on a backboard because people commented on how they didn't have much surface space and it would be really good if they were mounted on the wall. So from then on, all the other machines I've done have had a solid base. Sometimes it's been with ply, which is good because it's quite stable, and other times it's been slightly raised from the wall to give room for electronics and bits behind it, and other times it's been cut out of 3mm ply on the laser cutter, which is good, especially for the smaller machines like the chronograph, where the laser can engrave the number, particular number, and the eyes to hang it up with the keyhole slots and everything just out of a single piece of cut wood. And I think with this now, Is It Time for Tea Machine, I'm going to go with that version of things. I've got lots of ply. Let me move this back a bit and possibly even up a bit and possibly even down a bit. So this is the ply. I had it pre-cut by the company, online company, to fit the laser cutter, so it's 600 by 300 I think. It was just convenient, and it's also nice to have some design constraints. If the sky's the limit and you're not limited by money or size or anything, it's all a little bit tricky, because it's nice to have some constraints to work to. So I've got this, and one of the premises, or one of the things, promises even, that I said about the Is It Time for Tea machine was that I was going to try and avoid buying too much. I was going to try and just use up stuff that I already had here. I know that didn't really ring true with a 3D printer, but that was a good long-term investment. So I've got this wood, so I'm going to use this wood. It's 3mm thick, it's ply, so it's fairly rigid and stable. It's a bit bendy, so obviously a lot of the strength from this structure is going to have to come from little bits of pine reinforcing the corners, and that will give it its rigidity. The grain goes upwards, and really with a machine like this or an enclosure, it's nice if the longest side has got the grain going upwards, and I think it might look a bit odd if it went horizontally. So, lots of constraints, lots of things to think about. I think I'm going to sit down at the computer with the CAD software and just sketch out. I now know the size of the head, I know the height of this thing and how wide it needs to be for the little window that you're going to be able to see all this moving. So I'm getting a picture of how large it needs to be. I need it to be wide enough to support some displays of some sort where all the gauges and things are going to be that the head's going to consult. And I think I've decided to call the head Florence. I think her name is Florence. So Florence needs to be able to look one lot of gauges and the other lot of gauges, whoops, which are going to be working gauges as well, in order to come up with the conclusion that is it time for tea or not. So I'm going to start off by getting some measurements, really basic measurements, just so I can put them into the computer if you like. So you've got the head, you've got that.